Welcome to Brain Vision.
Well, we know that in collision of all kinds, since there is no external net force on the system, the total momentum before the collision equals the total momentum after the collision. So P1, that's momentum before collision, is equal to P2. Well, P2 is momentum after collision. Well, if the collision is between two particles, say A and B, then we get PA1 plus PB1, right, is equal to total momentum after collision, PB2, right? Well, let's call this equation number 1. And we know that momentum is given by mass times velocity. Well, let this be our equation number 2. Well, since the forces that the two cars are exerting on each other is very large, then we can ignore any external net horizontal force on the system. So the momentum of the system is conserved. Let the subscripts A and B indicate to the heavier car and the lighter car respectively. Let's do part A. Now, applying equation 1 to the two cars and then rearranging, we have, so this is part A, we have PA2 minus PA1 is equal to PB1 minus PB2, and change in momentum of A is equal to negative of change in momentum of B, and taking only magnitude, we see that change in momentum of A is equal to change in momentum of B, right? Well, so the change in momentum of car A equals the change in momentum for car B. It is only momentum gain for car A and momentum loss for it is only momentum gain for car B and momentum loss for car A. And according to equation 2, we have mass of A times change in velocity of A is equal to mass of B times delta V times B. So delta VA divided by delta VB, right? So this is not V times B, this is VB, B is a subscript, and that's equal to MB divided by MA. So the ratio is equal to 1200 divided by 3000, and that is equal to 0.4. And also we can write delta VA divided by delta VB is equal to 0.4. Let be this R1. Well, since we have delta VA divided by delta VB, right? So delta VB is less than 1. So we have here delta VB, delta VB is greater than delta VA. So the change in velocity for car B is larger than that for car A. Now part B, well, delta VA is equal to delta V as given, right? So we have delta V divided by delta VB is equal to 0.4. So delta VB is equal to delta V divided by 0.4, and that is equal to 2.5 times delta V. And let's do part C. Well, according to Newton's second law in terms of momentum, the two cars are exerting the same force on each other but the lighter car suffers more since the force yielding larger acceleration on it than did for the heavier car, right? Okay,